Hello everyone. So today we have x plus 1 in bracket times x plus 2 in bracket times x plus 3 in bracket times x plus 4 in bracket all equal to 120. So we are going to solve together. Let's say solution. Here, let's rearrange the equation as x plus 1 times x plus 4 times x plus 2 and lastly x plus 3 all equal to 120. So here we're going to use the first to multiply the second and the third to multiply the fourth. That is, x times x is s squared, x times 4s plus 4x, and 1 times s, and that is s, and 1 times 4, that is 4. For this part, put it in brackets, and on this other part, x times x, that is s squared, and x times 3s plus 3x, and 2 times s, that is 2x, plus 2 times 3, and is 6. We close the bracket. This is all equal to 120, and we are fine. So next, we're going to simplify further. Ask x to the power of 2 for here, and 4x plus s, that is 5x plus 5x plus 4. Close the bracket and open the bracket for this part, and this is s squared, 3x plus 2s, that is 5x plus 6, all equal to 120. So on this line, the equation is already taking a trend. S squared, 5x, 5x, 4, and this is 6. So we are going to split 6 into 4 plus 2 so that we can have it as x to the power of 2 plus 5x plus 4 for the first part into x to the power of 2 plus 5s plus 4 and plus 2 all equal to 120, and we are fine because 4 plus 2 is equals to 6. So next we are going to say let s squared plus 5s plus 4 be represented with k. So if we agree on this, the next line will therefore becomes here, this is k times k plus 2, since s squared plus 5x plus 4 is equals to k, all equals to 120. So if you do this very well, we're going to come up with k to the power of 2 plus 2k minus 120 all equal to 0. And this is a quadratic equation. So to get the product P is given as 1, the coefficient of k squared times minus 120, that's 1 times minus 120, and this is minus 120. And this obviously 12 times minus 10. And also the sum is equal to 2, the coefficient of k, which is 12 minus 10. So here, our equation therefore will become k squared plus 12k minus 10k minus 120 equal to 0. So to carry out factorization of this, we are going to have k squared divided by k, this is k, and 12k divided by k, as plus 12, close the bracket. What is common here is minus 10, open the bracket, minus 10k divided by minus 10, that to be left with k, and minus 120 divided by minus 10, that will be plus 12, all equal to 0. So to write the common terms is we have k plus 12, k plus 12. We are going to write it once as k plus 12 in bracket. So after writing k plus 12, what is left here is k. And after writing k plus 12, what is left is minus 10. Close the bracket, all equal to 0. Here, this leaves us with two solutions that says either k plus 12 is equal to 0 or k minus 10 is equal to 0. So from here, k is equals to minus 12, and here k is equals to 10. But recall that we assume k to be s squared plus 5s plus 4. So k is equal to s squared plus 5x plus 4. And now we have k as minus 12 and 10. So for k equals to minus 12, s squared plus 5s plus 4 will be equals to minus 12. And if you do this very well, we're going to come up with s squared plus 5s plus 4 minus plus 12 equals to 0. And this means s squared plus 5s plus 16 is equal to 0. S squared plus 5s plus 16 is equal to 0. So using quadratic formula, s is given to be minus b plus or minus square root of b squared minus 4ac all over 2a. And from here, a is 1, b is 5, and c is 16. So if we put in our values, s therefore will be equal to minus 5 plus or minus square root of 5 squared minus 4 times 1 times 16 all over 2 times 1. A is 1. So s is equal to minus 5 plus or minus 5 times 5, that is 25, minus 4 times 1 is 4, and 4 times 6 is 24. Put down 4, carry 2, 4 times 1, that is 4, plus 2 is 6, all over 2. So if we solve further, we're having s as equal to minus 5 plus or minus square root of here 25 minus 64, that is minus 39 all over 2. And this can also be written as s equals to minus 5 plus or minus square root of 39 times minus 1 all over 2. And since the square root of minus 1 is I, s therefore will now be minus 5 plus or minus square root of 39 I all over 2. So from here we have two values of s. S1 is equals to minus 5 plus square root of 39I all over 2. And x2 is equals to minus 5 minus square root of 39I all over 2. But these are imaginary numbers because they are not in anywhere on the number line. So for k equals to 10, s squared plus 5s plus 4 will be equals to 10. So that s squared plus 5s plus 4 minus 10 can be equal to 0. So if we solve this one, we have s squared plus 5s minus 6 is equal to 0. So we're going to use factorization method so that the product, which is 1 times minus 6, is equal to minus 6. And this can be obtained by 6 times minus 1, and the sum, which is 5, can also be obtained from 6 plus minus 1. So that 6 minus 1 is equals to 5. So the equation therefore becomes s squared plus 6s minus s minus 6 is equal to 0. So if we factor out s squared over s to be x plus 6s over s will be 6. And here what is common is minus 1. Open the bracket. Minus s divided by minus 1 to be x. Minus 6 divided by minus 1, that will be plus 6. Close the bracket, equal to 0. S plus 6 is common, so we write it as s plus 6 once. Open the bracket. So when you take s plus 6 from this time, it will be left with x. And when you take s plus 6 from here, it's left with minus 1. And this is equal to 0. This also leaves us with two solutions. That is, x plus 6 is equal to 0, or x minus 1 is equal to 0. And from this side, s is equals to minus 6. And while here, s is equals to 1. So these are the proven true natural values of s that can satisfy the original equation. But to be sure of this, we are going to verify. So from our original equation, which is s plus 1, s plus 2, x plus 3 times s plus 4 equals to 120. So to check, s will be replaced with minus 6. That is, for s equals to minus 6, this our equation becomes minus 6 plus 1, minus 6 plus 2, minus 6 plus 3, minus 6 plus 4. Can this be equal to 120? So if we solve this, we're going to come up with minus 6 plus 1 is minus 5 times here, minus 4 times here, minus 3, and obviously minus 2. We want to show if this will be equals to 120. And if we do this very well, minus 5 times minus 4 would give us 20, times minus 3 times minus 2, that is 6. Can this be equals to 120? And 20 times 6 obviously is 120 and is equal to 120. So it is true for s equals to minus 6. So for s equals to 1, s plus 1, x plus 2, s plus 3, s plus 4 equals to 120. So again, 1 plus 1 times 1 plus 2 times 1 plus 3 and 1 plus 4. Can this be equals to 120? 1 plus 1, that is 2, times 1 plus 3 is 3, times 1 plus 3, that is 4, times 1 plus 4 is 5. We want to know if this is equal to 120. So if you multiply this, 2 times 3, that is 6, times 4 times 5 is 20. Can this be equal to 120? So 6 times 20, that is 120, is equal to 120. So it is also true for s equals to 1. That is, the value of s equals to minus 6 and s equals to 1 are correct, which are the true natural value of s. Thank you for staying tuned. See you in the next video. Please, if you love what we're doing here on this channel, subscribe, like, and share so that more persons can have access to the skills that we're displaying here. Bye-bye.